The PDF for a continuous random variable is stated as f of x is 4/15 of x cubed for x between 1 and 2 and 0 otherwise. We want to find the CDF and use it to calculate the probability that x is between 1.3 and 1.7. Well, let's just get a picture of what we're doing here. So this is a graph of our function. So we'll have x and f of x up here. And then it's 4/15 of x cubed between 1 and 2. So let's say that that's shaped something like that, where this is 1 and this is 2. And of course, it's going to be 0 going off that way and off this way. So what exactly are we after here? So for some value x that's between 1 and 2, the probability of x being less than or equal to x would be this area that we've drawn here. We can find that area by integrating. So I'm going to integrate from 1 to x 4/15 of t cubed dt. Now I'm using a different variable here because I've used x up here. It's unlikely you'd get penalized for using x again here, but it won't work on the CAS, so just be careful, you need to use another variable. So that's going to give me 4/15 of t to the 4 over 4 from 1 to x, and of course those 4's will cancel there. And so I have t to the 4 over 15 from 1 to x, which is going to give me x to the 4 over 15. Take away 1 over 15, or if you like, 1/15 of x to the 4, take away 1. Now it's always worth checking with these things that they make sense. What do I mean by that? The PDF is 0 all the way along here, so when we get to 1, we should have 0 probability. When x is 1, 1 to the 4 take away 1 is 0, so it is 0. But the end of the non-zero part of our PDF is at 2. So when we get to here, our probability should be 1. 2 to the 4 is 16, take away 1 is 15, times 1 over 15th is 1. So that works. So to state our CDF, and we usually use the capital F when it's the CDF, so that's going to be 0 when x is less than 1. It's then going to be 1/15 of x to the 4 take away 1 when x is between 1 and 2. Once we've reached here, the probability is 1. So the probability that x is less than or equal to 2 is 1. Remember, that's the same as saying f of 2. Well, it makes sense that the probability that x is less than or equal to 3 is 1 as well, because we've already had all of the probability that we have. So this is 1 for x greater than 2. Now we want to use this to calculate this. So let's just make a bit of space on this diagram here. Okay, so if we think about f of 1.7. So that's going to be this area just here. And then if I consider f of 1.3, that would be this area here. So if I do f of 1.7, take away f of 1.3, then what I get is this area. And that's the area we want, the probability that x is between 1.3 and 1.7. So the probability that x is between 1.3 and 1.7 is going to be f of 1.7 take away f of 1.3. So that's going to be 1/15, let's just take the 1/15 out, of 1.7 to the 4 take away 1, take away 1.3 to the 4 take away 1. So we just need to calculate that. So I've calculated that and it gives me 229 over 625, and that's at 0.3664 as a decimal.